Hello, everyone. We are back live on our favorite YouTube channel about Kotlin, where we talk about various applications of our favorite programming language. And we are on YouTube and we are on Twitch, so you can watch us wherever you want. I'm Anton. I'm a developer advocate in Kotlin team, and today with me I have Gaetan, who is going to talk about Kotlin coroutines and interesting application for this technology. Hello, Gaetan.
Hello, Anton. Thank you for the invitation.
Yeah, thanks for coming. In fact, we are going to talk about transforming data and bringing it from point A into point B, right?
Yes, exactly. So today I'm going to talk about my experience about inside data engineering teams, which usually use a lot of tools, but not don't think of Kotlin at the first way of doing that. And I found some place where Kotlin and coroutines could be very interesting to replace some other technologies. So this is what I'm going to talk about today.
Nice, nice. That's a engineering task that is very close to my heart. Ages ago, I used to build applications that were, doing all kind of data transformation between the sources. Take the data from the file, throw it into database. Take the data from the database, throw it into queue. Take it from queue, throw it somewhere else. Enrich, transform, and then we had to do a lot of optimizations. At that time we didn't have Kotlin coroutines, and we had very slow machines as well. I think it was Java 1.4, 1.5.
Or, yeah,
So yeah,
yeah,
so it was challenging task from another angle.
yeah,
uh
imagine.
yeah, so folks who are joining us on the stream, feel free to ask questions. Gaetan is going to, do a presentation, show the demos. Once you have any question, type it in the chat. If you have a good moment, I will interrupt him and ask the question. Otherwise, the floor is yours, Gaetan. Take it further, and we are happy to, learn from your wisdom.
Okay, thanks a lot. So first I'm going to just present myself. So my name is Gaëtan Zoritchak. I've been programming since 25 years now. And I've been using a lot of languages like Java, Groovy, Scala, Kotlin, but also Python. More recently Python, a long time ago, and more recently. I usually I work mostly on the server side, but I also sometimes work on the client side for both web application or also Kotlin multi-platform, but on the client side. I started Kotlin from day one, the day it was announced, not before. And my work is mainly focused on software, on data, and also on architecture. So it could be architecture, software architecture, but also, more enterprise architecture. And I found in the company, which is named Data2Viz, with some other folks. And the idea is to really work from data to visualization, in the idea of working with the data, ingesting, transforming the data, and also working on the visualization part. And for that, we built some libraries and some Kotlin multi-platform libraries. First one is Data2Viz, which is a kind of low-level library, a visualization library. And also we have charts.kt, which is more a charting library. And we also do some consultancy on all those subjects, data and Kotlin and visualization. So today, what I'm going to talk about is mainly this use case. I have some data as some source file in a CSV. It could be something else than CSV, but today I will use CSV. And this data is in Google Storage. And I want to push this data into BigQuery for further modification. Today, we are mainly using not the ETL, but the more ELT paradigm, which means that we usually try to load the data into the backend, into BigQuery, and then we are doing transformation using tools like dbt, for example. For this particular use case, what is quite often used is this kind of stuff. So here I'm going to talk essentially about the Google environment, so GCP, and I'm going to talk about the tools and the brand used in GCP. So inside the GCP, what you have is Apache Beam. So Apache Beam is Apache Beam in GCP is named Dataflow, and it's a way to define your pipeline and your transformation from the source to BigQuery using either Python code or JVM code that could be Java or Kotlin. And using this description of this configuration of your pipeline, you are defining the different steps of your transformation of your pipeline, like reading the file from its source, doing some kind of transformation, validation, so some kind of stuff like that, and then writing the data inside a table in BigQuery. And what Dataflow provides is the way of scaling that process, managing the parallelization for you, and all that stuff. But it comes with a cost because Dataflow and Apache Beam is it's more than a library, it's more a tool. It's going to start, a worker pool or all this kind of stuff. And at one moment, I thought, okay, maybe we can do better by just writing pure Kotlin code. So what I'm going to show you today is how I'm just replacing, doing the same, but using Kotlin instead of pure Kotlin, instead of having a description through a configuration of a pipeline in Dataflow. So the goal of this ingestion is first to have good performance, because we want to have the global execution time the smallest. We want robustness, and this robustness comes with a stable memory consumption, because you can have huge files and you need to be sure that your process is going to work all the time, and you are not going to reach some limits and have an out of memory error, for example. And also what I really like is having efficient development and runtime environments. I mean, being able to run the code locally, to test it, and to have a quick feedback loop is something that is what I find really interesting when I need to work on this kind of stuff. So to go a little bit in detail to the idea of having a stable memory consumption is and how do we respond to what is the answer to that is to use call stream. So the idea of the call stream is to be sure that we are not going to load data into the process until the downstream process didn't push the data on the downstream element on the table, so that you are not doing some hot loading of data in memory, and you are able to at any moment control the amount of element that are in your JVM. So to do that, what we have and what is really important in Kotlin and in Coroutines is the channel. So the idea of the channel is that the channel is this blocking queue, which can have a capacity, and you give a capacity. So here, for example, if I give a capacity of 10, there will be no there will be no more element than 10 inside the channel, and the producer, which uses a send function. This send function is a suspendable function, and is going to suspend until there is enough space in the channel to put another element in it. And it's the same on the consumer side, for which the receive function is suspendable. So the consumer is trying to consume the element inside in the channel, but if there is no more element, is going to suspend. So this is the key element for this scenario. For the parallelization, the idea is to say, okay, instead of using a lot of worker to separate the operation, we have now machine that can have a lot of CPUs, and we can make use of those CPUs to do all the processing. So instead of having, inter-processus communication, what we are going to have is mainly we are going to stay in the same JVM and just parallelize the work using different threads. So here it will be coroutines, but at the end it's threads. And again, we are going to use the channel to do this parallelization of treatment. So here I have again a channel that have 10 elements, and I can use the same number or less or more processor to process the elements that are in the channel. So this is also what we are going to use, again, the channel to manage the parallelization of the work. So the whole flow, the whole code stream is this one. So on one side we have our file, on the other side we have the BigQuery table, and the element that controls both parts of the flow is the channel. So until the channel reach 10 elements in it, so here I keep 10 elements as an example, but it can be more. What is going to happen is that we are going to read bytes from the source. So here we are using the storage API, and the storage API is providing us with the IO channels. And these channels, basically under the hood, is making HTTP requests using 2 MB chunk elements. So we are going to load the source file using 2 MB array of data. Then we are going to put a buffered word on top of this channel, and we are going to parse directly the data coming from this buffered reader. From this part, we are going to create a flow of record, a CSV record. And then from this flow, so this flow, we are going to link this flow on this channel. So this flow is going to insert the element in the channel, send the element in the channel as soon as there is enough space in the channel to do that. And on the downstream, we are going to install all the transformation and write code to push this data into BigQuery. And so this is what I'm going to show you now. So let's go to the code to see that. So this is my project. I have a main class, a main file where I'm going to do all the work. So all the specific code will be here, and then I have some utility functions, and I will go into the utility function. So if you want to have more information, I can go a little bit deeper, but we are starting from here. So I just created the variable that I need. And to start, I'm going to open the API on storage. So for that, I created, so storage project ID is just some utility function that I created to just get a reference on the storage API using a specific project ID. And on that, I can get my blob. So my blob, sorry, I need to show you also where I'm going to push the data. A little step back. So here is BigQuery, where I have a project with a data set and just one table. And this table is quite simple. You see it has only 4 columns, A, B, C, D, with different types. And I have 2 metadata columns, which are file names and inserted at columns. And then on storage, I have these 200 megabyte CSV file, and I'm just going to take the data from here and push it into this table. So I think I removed all that was in it. Yes, so we have nothing. And okay, so for the moment it's empty. So I'm going to load the data from my bucket. So bucket name, file name. So this is to get reference on the blob. And I'm just going to check that I have access to my blob. And I'm going to say, okay, 8 size, and I'm going to just divide it like that. And we are just going to run it. So, okay, you see, I can access my blob and get the information on my blob. So this is really fast because it's only taking the metadata from the file. Now I want to create my buffered reader. So I created this extension function on blob. So this one is just a small one that is going to create a buffered reader on the read channel. So using an extension function on blob allows me to have this nice way of interacting with my blob. So here reader is a function from the Google API, the blob API, and I just create a buffered reader on that. So here I have a buffered reader, and on the buffered reader, I can use the line just to check. So this is a sequence, so I can just do the same and count the number of lines that I have in my file. So hopefully it's a good check to see if my connection is correct, because now I just downloaded the whole 200 megabytes on my computer to parse it and count the lines. So you see here that I have 3 million rows, and now it took me around 3 seconds to load this data from the server. Okay, so I'm going to put this reader in a variable, because what I want to do is not use pure directly my reader, but I want to parse it. So for that, I have I use the Apache Common CSV library to parse directly the reader. And if I do that, now what I'm going to have, so when you call parse, you get a CSV parser, and the CSV parser is an iterable of CSV record, which means that I can use again, I can use count on the iterable, or I can transform it in a flow. So now if I do as flow, now what I get is a flow of CSV record. But because I don't want to manage the CSV lines one by one, I want to process them as a micro batch. So to do that, I have another extension function on flow, which is chunked, and it will send me, so just to show you before, I'm going to also log info it count records. So now it's going to process the flow. So I have as much records as I had, had some lines, and now I'm going to chunk this by 2000, arbitrary number, and I'm going to do the same.
It's interesting. I've been using this also function for the same purposes when you're working with streams of data. It's so easy to throw the also function in, log something, and when you don't need it, just comment it out. Like,
yeah, exactly. So now you see that I have 2000 less chunks that I had rows. Just to see the chunk function. So chunk here is an extension function on a flow, and basically what it does is that it collects elements from the flow, it creates a new flow, and it collects elements from the current flow, put them in a list. When the list has a size of the chunk size that we are expected, it's going to emit this new element, the new list. And at the end of the collected, there are still elements in my array list. I just emit the remaining elements. So just a small utility extension function, but quite interesting, that can be used in a lot of context. So, sorry. Okay, so now I have my chunks of a flow of list of CSV record. Now I'm going to do my parallelization work. So for that, I also have another extension function, which is parallel processing. And this parallel processing, I'm going to have a look on it. So this one is doing this work here. So it's going to take a flow, create a channel, take the elements from the flow to send them in the channel, and then give the execution to the lambda that I'm going to give to it. So it's a small utility function, again, but quite interesting. So if we look at it, so this parallel processing have a default parameter, which is the parallelism that I want. So by default, I took 20. And so it's an extension function on a flow. And it's going to create the channel with the size of the parallelism that we want. And it's going to collect the element from the current flow. So this is the collect. And it's going to send the element on the channel. When there is no more element in the flow, it just closes the channel. So this is for the upper stream. so to collect the element and to send the element in the channel. And on the consumer part, I'm going to launch as much coroutine as I wanted my parallelism. So here I'm going to launch, for example, 20 coroutines. And each coroutine is going to wait for element from the channel, and it's going to apply the lambda to do the work and process as we asked for. So again, just an operator, quite generic, but that could be used in a lot of use cases. So so here I'm just going, I have a small utility class, and I'm going to use this class to just collect the statistic. Okay, so now I'm going to run it, and here I can put another log info, not that thing IT size up elements, and okay, I'm just going to execute this one. So here you see that I processed, so in 3 seconds I processed all my micro batch of rows, but it was all on the same worker because it was so fast that it didn't need to use another thread to do the work. So if I put some delay, I don't know if I put some delay here, we'll see that okay, now it's taking more thread to do the work. Okay, but so this is not what I want to do. What I want to do is push this data into my table. So now we are going to interact with BigQuery. And for that, when you use BigQuery, you have 2 APIs. You have the first API, which is the legacy API, and which uses HTTP request and JSON for the communication between your client and the server. And now you have another API, which is called BigQuery Write Storage API, and which is using under the hood protobuf. So it's a little bit more complex to use, but also it's much more performant. And this is why Google is charging you less money when you use this API instead of the first one. So what I'm going to use is this proto API. And so first, I'm going to create sorry, I also forgot to do something. So now I need, from my table ID, I'm going to create what I call a proto writer. And a proto writer is, so this is a class that I created because when you are dealing with protobuf, it's not that simple, and you need to have, the definition, the descriptor of your message. And you can retrieve a description of the message from the table schema. So this is what I'm doing when I'm creating this proto writer class. Basically, I'm getting the descriptor, the proto descriptor of my table. And also, I'm creating a stream writer that is the one that I'm going to use to push the data on this big table. And this is what I do, initializing all that stuff to then be able to push the data in BigQuery. And then the two other functions that we have, so we have close, of course, at the end to release everything that we need. And we have this append rows where I just append proto rows messages, which are basically bytes. And one interesting stuff here is because the API is not using Kotlin and is using Google has its own future implementation interface and all that. We need to make an adapter to go from their API to the Coroutine API. So this is how we do. So this function is from the API, from the Google API, and it's returning an API feature, okay? And what we have here is an extension function on the API feature to launch a coroutine and transform my signature from the Google signature to a coroutine signature and having a suspendable function. So now my proto writer has a suspend function instead of having to manage the API feature from Google API. Okay, let's go back. So this is my proto writer, and now I have my row builders. So now I'm going to iterate on my records. It's basically correct. Add serialized rows, and here I'm going to initialize val now equals cloud system now to protofield. So here I have some I have a file which is protobuf converter where I do all the conversion from Kotlin or Java object to what protobuf is expecting. So typically an instant you have to represent an instant by a long. So I just create an extension function for that. And okay. And now rows again. Okay. And write append rows. And I need also to close the writer. Okay. Okay, so this is Google API, so it's a little bit chatty. So I have okay. So now you see that my code did the ingestion of the rows in 9 seconds, and I can check that here. So you see, I have my 3 million rows ingested just now, and so I'm going to put some more information because I'm just going to add some statistics. So here I'm going to create before process equals system nanotime. here val after process equals nanotime, val after request equals system nanotime, and I'm going to put more data in at process duration. So it's after process minus before process, and stats add request duration after request minus after process. Okay, so we launch it. Okay, so now we see the time spent on the different part of the code, and so my whole my whole process take less than 10 seconds, and I spent a total of 2 minutes 40 seconds in the request calling BigQuery. And I spent only 6 seconds in the processing of my my file. So this is also because in this case I have really small. I have only 4 columns, and I don't do a lot of modification. So, for example, if you have to ingest a lot of date or instant, you are going to have a lot of parsing the date, parsing that stuff, and it's going to push more pressure on the CPU. This is not the case here. And it's also because I have quite a fast computer that I don't spend too much time on the CPU part. I don't know if you have questions or not, but I'm going to show how I can deploy that now on the server. Is it okay? Okay, let's go. Okay, so now I'm going to show you how. So for the moment, we developed, and here we have basically all the code. So it's not very generic code, so it could be changed a little bit. And this part, so here I have the code to do the transformation from the CSV to my specific table. So this part could be much more generic. But for the demonstration, I did just a small implementation in quite simplified implementation of it. But basically, all the code is here. I mean, all the rest is only small utility functions that are very generic and can be reused in different contexts. Okay. I'm going to show you how I can we are going to deploy that on Google infrastructure. So basically, it's also quite easy. You have this plugin, which is Jib, and this plugin is going to create a Docker image for you. So you see the usage is quite simple. You just declare where you are going to push your image. So here I'm going to push this image into my project in the artifact registry URL of my project. And I'm using the tag from my version here. So doing that, I just launch the Jib, the Jib task, and you see it's quite fast. So it's not fast, not only because I have a good connection, but it's also fast because Jib is optimizing a lot the layer of your Docker image. So if you don't change your libraries, all the libraries are going to stay in lower layer of your Docker image, and it's only going to change the last layer where you have your compilation, your class, your bytecode, basically. So this is really efficient. And if I go on my artifact registry, I can refresh my artifact registry, and you see that I have a new version of my Docker image, which is available now. And I'm going to use Cloud Run to create a job to run my code. So in Cloud Run, so Cloud Run basically is a cluster, a Kubernetes environment managed for you, and you can use it to deploy either service to manage, for example, microservice or web application, this kind of stuff. Or you can create jobs, which are more batch processing. So this is what I'm going to do. I'm going to select my image. So here I have my image. I select it. Okay, select. I'm going to run it in Europe. Okay. And I'm going to use eight core. So I need a minimum of 4 gigabyte. Okay. So now I have my my new job, and I can execute it. So now it's going to start my job. And I can look at the logs, and it's better for the logs to look. I find it better to look the logs inside the log explorer. Okay, what I'm going to do is I'm going to remove the selection to the specific instance to use always the same log explorer to see all the logs from my from all the execution. So here you see that it took approximately the same time to do to run it. So it took less than 10 seconds. But this time I spent more time on the process. So this is because in Cloud Run you can't choose the type of machine on which it's running. So it's good CPU, but not really performance CPUs. And the I/O part took much less time because, of course, everything is run inside Google network. And
let's clarify a little bit, because it seems that people are a little confused in the chat. So in the beginning, what we tried, we were running the application, the program, Kotlin program, on your machine, right?
Exactly.
Now it was complete, and we built the Docker image and we deployed it into Cloud Run. And now what we see on the screen is the log from the cloud environment, right?
Exactly. This is exactly the case. And so it's good that it's not very clear. The good part of it, I think, is that there is not a lot of difference between the two environments. And you see, I can work locally using working on a distant file and on a distant BigQuery. It's exactly the same code that I'm executing inside Cloud Run. And this is also because, so I didn't show you, but maybe I can go back on that. Okay, let's clean a little bit this part. But here, for example, when I open storage, I use the default credential. So default credential is a way in GCP to log in GCP. And when I start a session every morning, what I do is I'm launching this command, which is gcloud login update application default credential. And with this command, I'm going to log in using the browser to my project, Google, and saying, okay, I allow Google to have access to my project, etc. And this command is going to get a file, a token that is going to be valid for the day. And now this, when I want to access to an API, the first thing the client API is doing is checking for the existence of this token, either in a specific location on my computer or as an environment variable. And on the server side, it's using exactly the same way, but on the server side, the application default will be available as an environment variable. So I don't have to change anything, and my code is running exactly the same way on both environments. Okay, so just to show you, so here, if I go back on the configuration of my Cloud Run, and if I reduce the number of CPU to 2, maybe it's very low, and I run it, we'll see that the number of CPU is really impacting the speed of the execution. It's okay, it started.
While it's running, I think it's a good time to ask the question from the chat. So, do you think you achieved the goal for the better performance? If so, how much do you attribute to the concurrency model and how much you actually attribute to the solution itself?
Okay, so there are a few answers to that. So when I did that work in existing companies, in the average, the performance were 10 times faster than using Dataflow and the Dataflow and Python implementation. But we have to mitigate these results. One reason was also because the Python implementation was using, the Panda CSV parser, which is not that performant. So a part of the time was due to the bad parsing performance of the CSV Panda parser. But also what is completely different is that when you are using, for example, Dataflow, you are spanning a lot of workers, and now those workers have to exchange information and all that. And me, I'm just running in the same JVM, so there is a lot of gain, having just exchanging data inside the same JVM. So this is really faster. And also, so the 10 times faster was for really big files, but also which was really kind of crazy was for smaller files. So because here you see I take 200 megabytes, it take less than 10 seconds. And if you try to do that with Dataflow, the starting of Dataflow is already going to take a couple of minutes. So it's going to span a lot of workers to do something that then just take few seconds, but it took 3 minutes, 2 or 3 minutes just to start. So for this part, it was really a huge gain. And this gain was also on the price. And so the time was 10 times faster, but the benefit was 50 times, because here I'm just running, a node for a few seconds instead of running, dozens of workers for minutes. So at the end, if you cut your cost by 50, it can be really a lot.
Okay. So at the end, the cost for running this processes, have you calculated just mm, on average, like, or approximately how much money did you save actually with this solution?
It's hard to say the real numbers, but you can go from, for example, $10,000 each month to $200. So I mean, this is the kind of amount that you can have. So having
Nice.
something that you start to count to something that is no more, yeah, you don't see the line, so it's better.
I see.
So you see, if I take just two CPUs now, it's taking 20 seconds. But this is also because this particular file has not a lot of processing. So it would change also a lot, if in your processing lambda you put more stuff, more text, maybe filtering some data, etc. So in that case, you would have more time spent on the CPU part. And also, what is interesting is here I used Cloud Run, but you can have better performance if you are using um, um, Kubernetes. So if you are using Kubernetes, you can really choose, your node pool, and in the node pool, you can, choose a specific machine with really better CPUs, and to have also better performance here.
Right. There was also a question about the other cloud hosting. Could you implement the same thing using AWS?
Yeah, I mean, there is no, so here the code, there is okay. I mean, the main part are really, those small extension function, and they are not linked at all to any cloud. There is nothing specific here. So after, of course, here I would create another, but kind of the same stuff to get a buffer reader on a blob inside AWS. And of course, to push the data, I don't know where in AWS, I would implement it in another way. But the same could be, of course, reused without problem.
Right. So at the end, you still are deploying the Docker image, and
Yeah,
AWS provides also like the environment for this kind of deployments.
yeah, and also this even if it's created by Google, this plugin, which is the Jib plugin, it's not linked to Google. I mean, it's just you give uh, a Docker URL, a Docker repository, so it can be anything. It can be JFrog, it can be so absolutely no problem.
Nice, nice. All right. Uh, do we have any more questions in the chat? Let's see. Coroutines, state flow. There is an unclear question to me about coroutine state flow with DSLs.
I don't uh, I don't get the point in that use case. I mean, stateflow for me, we're using that more on client part.
Oh yeah, yeah, because the person mentioned Jetpack Compose, so it's more like a Android use case. I think
Yeah,
we're
yeah.
we're talking about server side right now, and it's for data processing, so it's a different use case. Um, yeah, there was a mention of virtual threads, of course. We could talk about this a little bit. So you're running on JDK. Which version was it?
So I just saw it was 21, but I didn't test anything on that because for me, um, I think I don't use so much, so because I'm using micro batches, so I don't have, tons of the number of coroutines is not that big, and I don't imagine that I can have, bigger numbers and better performance here. I mean, it's okay. It took 9 seconds and a half to push the data from one place
Hmm.
to the other place, but most of the time was spent in the network. So I don't imagine virtual threads changing something here.
I see. Yeah. Well, regarding virtual threads, we in the beginning of this year we had a session with Urs Peter, who was explaining the difference between Loom and coroutines. And if you're interested, you will find it on this channel as well. Theoretically, it should be possible to replace the dispatchers.io with the executor service with virtual threads for executing or for scheduling the coroutines that have blocking operations, and maybe then we would win something. But you cannot tell for sure because this needs testing, and
Yeah,
I honestly
and
I honestly haven't seen this kind of
yeah,
performance tests yet.
and here I don't have any on the BigQuery part. I don't have any blocking API. I mean, it's already a non-blocking API.
you know what I really like about your solution is that it's so clean. I mean, you don't really have a lot of dependencies there. Like, yes, you need the client libraries to communicate with the BigQuery and take the data in, but the whole processing engine is like a pure Kotlin with coroutines, and you just implemented a few operators that were, you know,
Yeah,
easy to implement. It seems, and was quite an elegant solution. So this is the beauty of it.
exactly. And for the robustness, uh, I never had problem with this implementation. I mean, it's running, I don't know, 1,000 times each day, and for months, and I mean, it just works. There is nothing else to say. You just have to look at the logs, and that's it. So yeah, just to as a conclusion. Uh, so for me, the development is really nice to be able, to work like that, to work locally on distant API without too much work. The deployment is also really cool. So the coroutine, it's good. I mean, what I really like with coroutines is the ability to do mainly whatever you want. So you have, for me, coroutine is a kind of grammar where you can write whatever you want. But it's not always completely easy, but this is normal because, I mean, multi-threading and all that stuff, parallel processing is hard. So you can simplify it, but you still need a little bit of competence to do that. So the performance are really cool, and the cost was really, it was a huge gain. And in this development, what um, was quite, I mean, the painful part, if you compare, for example, to Dataflow, is here I had to go in the BigQuery storage API. So this part, if you say to a guy, okay, do that using Dataflow, it's just going to use an operator and say, okay, I just want to push this data in this table, and that's it. Here I had to go inside the BigQuery storage API. It's not a long work. I mean, I was able to do that. And again, it's something that now is in some kind of utility class, so it's very generic, but it's something to do. And the development of coroutine operators. So at the end it's simple, but it needs a little bit of work, to really clearly understand what you are doing. Okay, and so if I have an advice, and I couldn't advise this more, if you need help on coroutine, first buy and read the book from Martin Moscala. So it's really a great book to give both a higher level comprehension of coroutines and also to give a lot of technical, specific detail and use cases on how to implement different stuff. And for me, I have the chance to have Louis Cad that is working partly in Data to Viz team, part-time in the team. So we discuss and we work on the code of this on this operator together. So it was nice to do that. So thanks to him.
Nice.
And if you need some help, also don't hesitate to call us.
Nice, nice. Regarding the book, since you mentioned the coroutines book, that's an awesome focused book on coroutines. In fact, we have a second edition of Kotlin in Action coming,
Yeah, I
which
saw that.
in
Yeah.
the first edition, it didn't have the chapter on coroutines because coroutines did not exist at that time.
Yeah, of course.
And the second edition now adds this this chapter on coroutines. So the book is out. So you can order that. Yeah, there was a question in the chat. If you can comment on that, I think it would be awesome. With what version of Kotlin, at least, do you recommend
I mean,
to try this solution?
this code would work with Kotlin from 1.6 to the last version, I think. What
Yeah.
I'm going to do, I'm going to maybe to push the code in some GitHub repository so
Yeah.
that if people want to use it and check it, it will
Yeah,
be
we,
available.
we we will add the link to the description so that everybody could find it. Just to add to this answer is that we generally support Kotlin versions, two major versions back from the current one. So today, the latest stable is 1.9.23, if I remember correctly. Two major versions back. It means 1.7, some latest minor release, but 2.0 is coming. It's almost
Yeah,
here. We just announced the
it will be
RC2.
here for the Kotlin Conf. We
Yeah,
hope that
so
it will
we
be
hope, we
the
really
announcement.
hope that it will be. It's less than a month. Hopefully, you never know. Like sometimes
Yeah.
testing takes longer than expected, but it's almost here. So I wouldn't like generally. I would recommend looking at the Kotlin version at least 1.8. But it's always great to get the latest stable, the hottest, the newest, and that brings all the new features. Um, follow us on Twitter. Follow us for the announcements, and you get the news. And we are waiting for 2.0 very soon. So with this, thanks, Gaetan, for this awesome
Thanks a lot.
presentation. I think people learned a lot, and we're gonna add the links that will complement your talk to the description of this video. Thanks everybody for coming, and have a nice Kotlin.